Okay, so let's get started. Hi, I'm Radha Dasari. I'm the Technical Education Lead at Web3 Foundation. Today, I was asked to talk about like Polkadot ecosystem and tooling, but I've chosen this particular session to explain in a sequence, because you're just graduating like PBA in a couple of days. You might want to explore avenues where you could actually develop, right? So one of them is like building like your own Parachain and launching it. This is going to give you an idea of like what exactly it takes, and then it opens up a lot more like options for you to explore. So let's see what I have today. Let's do this. This was working just a moment ago. Okay, so in today's session, like I'll also, put all the things you've learned so far, like most of the concepts together in terms of like Polkadot as a relay chain, and you have like these parachains, and how all of those come together. Yeah, so I typically start, introduction to Polkadot to diverse audience with this slide. So I just show this Kusama block that was produced in 2019. That's the first proof of concept of a execution sharded blockchain in production environment. So Polkadot is one of those. I'm sure you've heard of like others too, like Near Protocol or yeah. But we, as you've seen over the last 4 weeks, have made a lot of design decisions. One of the key decisions was to use like Rust programming language, and then sort of execute the the business logic in WASM, right? So you've done that. You were exploring how to build runtimes. You've customized them. You compiled them into this WASM blob with which like you were interacting. Cool. And yeah, so okay, so now that you have a custom runtime, what do you do with it? You could sort of create like your own validator set, and start like your own blockchain running in isolation, or you can explore connecting it to like Polkadot network. So the network has $1 billion security. So from block number 1, every transaction on your Parachain is going to be secured with that levels of economic security, right? So Polkadot network, it produces a block every 6 seconds. It's over like 20 million blocks right now, and then let's do. Yeah, and then it hosts like what are called parachains, right? So parachains are like these parallel blockchains, the blockchains that are running in parallel. And the idea is that each blockchain is tailored towards a specific use case. Now, I also try to show this snapshot just to give an idea. Just when I say there are parachains running, on Polkadot, this slide sort of gives you the actual thing of what's happening there. Anyway, so you can see individual like parachains, like Asset Hub has about, 21 million blocks there. And then you have a bunch of other chains, like each producing blocks. These are all like individual independent blockchains, sending like their blocks to Polkadot validators for validation. And then we have the system parachains, like I don't know how many of you have heard of them. So system parachains, they're considered part of Polkadot protocol. So to become one, you have to go through Polkadot governance, like OpenGov. And we have a bunch of those. I'm sure Sean covered them like yesterday for you. So the latest one that will go live on Polkadot is the code time chain, as well as people chain, which takes care of identity. And yeah, so Saraya, my colleague, like would have mentioned about grants program. So over like the past 3-4 years, we have funded a lot of projects which have spanned across like several disciplines. And Polkadot SDK, as you've learned, is capable of getting all these. If these fields have like a blockchain use case, Polkadot SDK has the tools for you to build a solution for that. Fine. So where are we headed? Like today, on Kusama network, which is sort of Polkadot's canary network, core time is live. So Agile core time, you're able to purchase core time like on demand. You can produce a block on demand, or you could also purchase like a bulk core time, which will let you produce blocks 24/7. So there are a couple of like really good, well-maintained websites out there that let you like buy core time on Kusama. So in a couple of months, you'll see this live on Polkadot. And that's why I say like this lecture is of a very good timing, because you are freshly graduating out of PBA. You have access to this feature, which others didn't. If you were part of like previous PBAs, to become a Parachain, you had to auction. You have to participate in an auction, probably raise a crowd loan, do a lot of work before like actually launching it, right? So this is gonna let you like launch a Parachain right after the Agile core time goes live on Polkadot. Okay, so this is sort of a marketing gimmick. So launch a Parachain in 2 hours. So there's some terms involved. So one is actually it's a fairly accurate number. It includes the time your computer takes to compile Polkadot SDK. Okay, so that could be from 30 minutes to, I don't know, 30 hours, depending on your computer. So yeah, given that you've compiled like your Parachain binary, most of the, so I'm just gonna show you, like without even like writing a single line of Rust code, you're able to launch a Parachain, what like Bitcoin can do, what Ethereum can do with governance and multi-sigs, proxies, account abstraction, whatever. So this is all possible in this time, and let's see how I did that. Okay, so the entry barrier is not all that low. I'm sure these are like bigger numbers. We're working on bringing them down. So these were originally the numbers if you wanted to launch a Parachain, with the current auction model, with all the crowd loans and enterprise, whatever. So the Agile core time, the idea is that a university student or someone could convince like their management to just have a Parachain on. So these numbers will definitely go low. So today I'll be showing you a demo with the Rococo, which is like a Polkadot testnet. You're able to get testnet faucet. There's a testnet faucet. All you need is like 200 Rococo tokens to sort of launch your Parachain and see it working. So there's also another testnet called as Passio. So it's currently just running the runtime of like Polkadot. It's just mirroring it. So when Agile core time is ready to ship on Polkadot, we're gonna have it on Passio as well. So consider like running as a Parachain there as well. Okay, so what do we do? So the first step, no matter what you do, you'll sometime be exposed to Polkadot.js UI, even if you want or don't want to. So the first step is to get your Parachain a unique identifier, right? So on Polkadot or on Rococo, on a relay chain, so you're going to first have to get this identifier, which identifies your Parachain. Not only here, but also you've learned about XCM. So when you're giving like XCM multi-location, this would be the Parachain ID that you'll be using there. So here, so the para ID, unfortunately, you can't get your lucky number. So it sort of gets incremented every time based on like availability. So right now, today, to launch PBA chain, I took like the ID 4452 and then 40 Rococo tokens as deposit. Fine. So now that I registered like an ID for my Parachain, I have to choose like what this chain is going to do, right? So it needs to have some business logic. So there are numerous like templates out there. What I'm showing you here is like templates from Polkadot SDK itself. So if you downloaded SDK, you'll see a minimal chain with like very minimal like palettes, basic palettes, and then a Parachain, which has like some XCM related config as well. Solo chain, if you don't plan to become like a Polkadot Parachain, there's a template for that in Polkadot SDK as well. So, and then we have a bunch of other templates from one from OpenZeppelin. It has like all the functionalities I mentioned earlier, like you have governance, multisigs, proxies, assets. You can mint, fungible and non-fungible assets there. Yeah, and then this is something fairly new. Like POP is sort of bringing all the templates under one umbrella, and then they have a nice command line. Explore that as well. And Tansy is actually providing parachains as a service. So that's something you would want to explore if you don't even want to follow like what I'm saying today. Okay, so I've chosen OpenZeppelin template for the PBA chain that I launched today, early this morning. So it comes with like a very nice documentation. Again, like the Polkadot documentation is going through an overhaul. So for now, I would say you could look at this too while launching a Parachain. So they've given detailed instructions on how to do it and all the palettes involved and stuff like that. Okay, so the first step, it's a template Parachain, right? So what I did was I personalized it. So I just replaced wherever it called like template to like PBA chain or whatever, and then the node itself took like 17 minutes. So then I can say 2 hours 17 minutes is just the time I took to launch this chain. Fine. So this is just compiling the OpenZeppelin like Parachain template node, and you would want to also like personalize it further. Like you want to change the token name to like PBA. You'd like to give decimals to that native token. Might want to add a pseudo account. Like initially your Parachain just has you, so probably you'd want some privileges to make changes on it. You'd want to also set some accounts with like preloaded balance. Some accounts should have some tokens to even like start paying for fees on your network, right? So I know you've done an assignment on feeless blockchain, whatever, but here on this chain, like you would need like it's fee based. So yeah, and then this one, I think this is a terminology you're not familiar with. So invulnerable is like the collator node that has the privilege to produce Parachain blocks, from the genesis. The moment like you bring the Parachain live, which collators are going to be allowed to produce blocks, and also you can add them like later on. There's like a collator selection palette where you could like configure that. Anyway, so you have this. I made the changes, and yeah. So what I did was I made the changes. I recompiled like the node. This takes like very little time, and then I produced like a JSON file. Okay, so it's going to contain like all the info. Okay, what's the protocol ID? What my token symbol? What relay chain I'm connecting to? And if you remember, we reserved the 4452 the para ID, right? So I've used that there, and then yeah. So and this is the command I sort of used to build that chain specification. So this is all the info that is needed for me. Or this is all the info, any particular node. You've heard of Omni node, or there's a Polkadot Parachain node. It just requires this to be able to, connect to your Parachain, collate to it if needed, and whatever. So now we have like a representation of like our Parachain. And the next step is to find. So I've compiled my Parachain. It's running on my machine. How I'm going to make this connection to Polkadot or Rococo, the relay chain, right? So that's where you have to have these two files generated. One is the genesis state, like what should be the state at the beginning of your Parachain. So I mentioned we are pre-funding some accounts. We are giving an account like a pseudo access. So all of that is embedded in this particular file. And then this is the PVF. So no, this is the state transition function of like Parachain, right? So that's where like all your code related to governance or staking or assets. It's all in there, and then we have like a bunch of like chain specs. So now the next step is, so you've reserved the para ID. Now is the time for you to register your Parachain code as well as your Genesis state. And this is like a very costly operation. So think of a typical, can anyone guess how much is the WASM file size of like Polkadot? It's actually 1.3 megabytes or so. So it's the compressed version. And then, so if you use like super minimal Parachain, then it's in kilobytes. But this one was like around like 1.2 megabytes or whatever. So you upload that. Yeah, so you see para 4452 WASM file. It's like around 1.2 megabytes. You've learned that blockchain state is like a, what do you call it? It's redundant and it's a costly thing to have something on there all the time. So uploading this amounts of data will incur a lot of deposit cost. And that's what you saw earlier, the deposit cost for registering your Parachain code as well as like Genesis state, it's gonna cost you. Fine, so after you do that, you have like 2 hours for your Parachain to be onboarded. And this is when I took a snapshot. So now the Parachain is onboarding. So I registered it. So now I'll take some time and again, showing you or making you appreciate like Polkadot design in general, what you've learned like in early lectures. So this is a slide from Sean. So this is an analogy we show when we show how Polkadot validator works. So you have like Polkadot WASM, that 1.3 megabyte WASM that is taking care of like validation of parachains out there, processing Polkadot transactions itself, fine. And the validator will also bring in these parachain WASM files. They load them from the state, and then when the collator sends like a block to the validator, the validator node is going to play a game, So they'll see like transactions happening in that block. They'll use this code to sort of process them and see whether they're compliant to this state transition function. So basically what we did was the PBA chain WASM code is now in the state, and then it's available for the Rococo validators to be fetched. And for that to be available, there's like this 2 hours onboarding process. So I can also show you how it works on Polkadot. So clearly you can see these are individual like parachains. You have Asset Hub, you have Collectives, Bridge Hub, or whatever. So each chain is producing a block, and that block is being sent to these set of validators. So there are like 5 of them, and they're getting like shuffled like very often, right? So that's the idea of like Polkadot's shared security. So it's hard to guess which validators will be assigned to which parachain. That's why you can't make a guess, and you'll have to attack the whole network. And that's why we say every parachain is going to enjoy the privilege of like the entire security of the network. And that's the reason. And this randomization, is the key to it. And we've gone even a bit further with like Jam. Tomorrow, I think Gav will talk about like Safrole and how this sort of like even is improved further. Fine, so now what collators, like the node that I'm running on my computer right now, so that would be a collator node. So it's listening to the transactions I send to it. So if I'm gonna ask one of you like your address to airdrop some edu tokens or like PBA tokens like later on, keep them handy. But the point being, if I initiate a transaction here, you have, so the collator is the one that has the transaction pool. It's going to listen to all of them. And when it gets a chance to like package these blocks and send it to like Polkadot validator, it makes a connection to those validators that are getting shuffled on like the relay chain. So the connection is made, the collator, like the block is sent and received at the validator end. And so I just want to take this time to rehash like what you learned about PVF and like state on like Parachain, how you express it to the relay chain validators. Yeah, so you can think of this as the state of the Parachain, right? So there are account balances. If you have like some democracy, then there's some info in there, some voting info or whatever. So there's Babe or some, yeah. So you can think of this as like the state of the Parachain. It's a Merkle tree. Now, when I'm just like airdropping some tokens or sending tokens to an address, so the interaction is only happening between a couple of them. So rest of the info stays like unchanged. So you're going to see that the hashes of the unchanged ones, they're going to be the same. You need not send all of this info. The info that you'll send as part of like the PVF is like this one, like the account that sent like a balance to a different account, maybe a change in like referenda palette or whatever. Fine. So yeah, so basically you're sending like a prune state in a way, and then and the relay chain already has the state transition function, right? So the Polkadot validators will plug in like PBA chains WASM code, and then they're going to run this transaction through and make sure like this transaction happened properly. Fine, so all this theory is good. Now let's see how to run this collator node, right? So a collator node, by default, they run a full node of your parachain itself, and then they run sort of a light client of the relay chain. You see, like there are two nodes that are running. One is the collator node, and then one is the relay chain node. Relay chain node because the parachain needs to know which of its transactions is final. And the only way it gets to know is by sneaking into like relay chains like, yeah. So basically looking at grandpa votes on the relay chain, the parachain knows like whether its block number so-and-so is sort of finalized or not. So fine, so this collator node is going to launch like two nodes. You could either do it like Open Zeppelin way, but this is pretty slow. So previously it has taken me like around 6 or 7 hours to sync with the actual Rococo chain. So instead I've used like Polkadot Parachain node available on Polkadot SDK. Yeah, maybe that also gives the option, but this one gives the option to directly connect to Rococo relay chain via like RPC. So I don't have to like spin up a Rococo relay chain node that has to sync with like, I don't know, 10 million blocks or whatever. It takes a lot of time. So now I have direct access to the latest blocks on Rococo. And then my collator, it need not even sync because I haven't even produced a block. So we are still at block 0. Fine, so what I did was I started this collator. For that, like the command I gave, so there are a bunch of like text there. The important one is I fed the Polkadot Parachain collator node with my raw parachain spec pba.json. Remember, I gave like the para ID and then a bunch of things about like my token or whatever. And once I connect to this collator node locally, so this is like localhost 8844 or whatever, yeah, 9944 or whichever port I assign to it. So I see that I've pre-funded some accounts with 3.3 or 3.4 million PBA tokens. Last block 0 seconds because we haven't even produced a block. Fine. So the collator is ready. Yeah.
Usually, for example, when we start a validator node, we have a flag for -- validator. Maybe I'm just missing something, but I can't see what is the flag that specifies that this is a collator node?
So Polkadot Parachain itself is like a collator style node, and it's just asking for, hey, what's the chain spec for that particular parachain, right? So it's sort of abstracting away the collator flag. So underneath it, it's like a node with like that collator flag. Cool. So now we have a PBA chain that's running on my computer with so much balance. Let's see what happens now. Now, the thing is, like in Genesis, I set what's called this invulnerables, right? So the relay chain sees this collator and like, who are you to produce this block on behalf of this parachain? So to answer that question, the collator node should have a key that was set as like invulnerable, like key, whatever we set initially in the Genesis. So for that, what we do is, there are two things. One key is going to be dealing with the collator's identity. So we don't want to reveal that seed phrase to anybody. Okay, so that's given. So there were instances where some parachains used like a default Alice and Bob keys or whatever, and then were surprised when somebody moved like tokens from their chain or whatever. So you'll have to, like, when you see the OpenZeppelin config, you'll see Alice and Bob keys there. Remove all of them. You put like your own keys, like something maybe from Hard Wallet for the collator identification. And the other one is called the session key. So the session key is meant to be rotated often because you're actually loading your seed phrase onto your machine. Like your machine has a key store, and then your session key is going to be living on that particular machine. So typically, it's a good practice for validators or collators to rotate these session keys. But anyway, so in the Genesis, we already said, hey, somebody with this ID and this session keys is going to knock on your door and then give you like a parachain block. So please validate it to the Polkadot or Rococo validators. So we did that, and we are able to do this via like a RPC connection to our node. Okay, so you're able to set stuff in there, and this requires like unsafe RPC options or whatever. There are better ways to do this, but through Polkadot.js, you are able to set these keys in your key store. Fine, so the next thing is, let's see if a basic transfer sort of works on this PBA chain. So what I did was, both are my accounts, like one is the EduChain account and the other one is my account. So I sent like 1,000 PBA tokens to myself, and then now this transaction is in the transaction pool. So can anybody tell me how to process this transaction? Now I have a collator, I made a transfer, sitting in the transaction pool. When will this transaction get executed? Yeah. Yeah, you have the mic there.
The transaction will get executed when the validator inside the relay chain actually validates the POV and
yeah, so I've waited for like 5 minutes and this transaction is not getting processed. So what am I missing here? So the validator is not still accepting my transaction.
oh, the validator is not accepting the transaction.
I mean, he's not even accepting the block that I've produced with this transaction. And the reason for that is agile core time, right? Like you have to pay the relay chain somehow. You need to either buy block space, like for producing like one block, or you should have access to the bulk core time to be able to produce like block, every 12 seconds. Very soon with async backing, like 6 seconds, some parachains are starting to, sort of implement that feature. So what I did was I went to Rococo and then I told the Rococo network, hey, so this is my parachain, like 4452. So that's the ID of my parachain. And then I'm going to the on-demand assignment provider palette and then having this place order allow death. Okay, so we have like these very intense naming in like Polkadot SDK. So there's place order allow death, whatever, and then you specify like a maximum amount you're willing to pay for it. So of course it won't use up everything. It'll only use like what's what's the current value for that on-demand block production. So when that goes through, you'll see that this transaction goes through on like your parachain. And then what happened? So we produced our first block. So we have the first block. So edu collator was like the identity that I had for the collator, which had like those session keys. So this is shown. the session key is not shown. That's why you see like validator identities like Binance or I don't know, Kraken or others in like Polkadot relay chain. So those are tied to those accounts on your hardware wallet, and then they keep rotating the session keys of it. So the transaction went through, so I got like 1,000 tokens, and all of those events are registered here. Okay, so I would say with everything involved, like it took me 3 years. You could actually go and see the snapshots of Rococo block numbers. It shows that I launched it today. You can also look at the events on Rococo. The Parachain was registered this morning. So it's not that difficult. Like, you know, you can have a Bitcoin style, Ethereum style, like blockchain that is running in 3 hours. Like using Polkadot SDK, you're able to create this blockchain. And then the problem is I can't let you connect with your Polkadot.js to the node that is running on my machine because I haven't set up like this secure connection. So that would be the next step, right? So you'd want to give your RPC node like a URL, and then you should be able to connect to it. So unfortunately, I didn't have that much time today to do all of that, but I can show something that we have already did with what we call EduChain. So the goal of that project is to just show people like how seamless it is to like launch like a production grade like blockchain on like Polkadot. So these are the steps that I would say would be logical next after you've done your first transaction on your Parachain. So set up the remote RPC node, integrate with Asset Hub. This comes with a lot of perks. Whatever PBA token I had right now, it's just in my local network. But integration with Asset Hub is going to allow me to register my token as a foreign asset on Asset Hub, create pools for it, pools with like dot token, or like if I'm on Kusama, like Kusama token, pay for all the XCM fee or you know any fee with my token instead of having like KSM, right? So that pool is going to take care of all of that. So that's a logical thing to do if you're launching a Parachain. Add additional pallets, you know, maybe put some identity pallet in there. And you could, if you do that, then the next logical step is to do on-chain upgrade. You can also do that on this collator node. You already have the sudo key. With that, you can set code and upgrade your Parachain. And the last thing, like if this doesn't suit like your use case, you develop your own custom pallet, which is what you did as one of the assignments. So you could totally do this, right? So right after code time goes live on Polkadot or it's already live on Kusama, you're able to write those applications you've been willing to or you know dreaming of like writing so long, and then change the world ultimately. Okay, so the remote RPC node setup, yeah, you need to purchase like a domain for it, and then maybe like run it on a cloud instance, run it as a service. So it's going to accept like connections from remote users. So this is the Web3 EduChain like RPC. We'll play around with it a little bit if we still have time. Yeah, we still have time. So yeah, so at this point, I'll do something practical rather than just showing you these slides. Let me show my browser. Fine. Okay, so let's go here. Okay, so we are in, is that, yeah, PBA chain like Rococo. Yeah, question.
It says the last block was 3 hours ago. Is that simply because of the core time thing, or?
Because I'm producing it on demand. So I produced the block 3 hours ago.
Yeah.
For this session, I put all the screenshots in the presentation, and now we're going to produce another block here. So let's do it. Okay, so let's go to accounts. What's it? Yeah. I think again, like the Polkadot.js API, you know how it works. So I don't think this is async backing enabled though. So it's fine. All right, so let's do one more transaction here. Accounts. Okay, where do I have it here? I'm going to send myself even more tokens. Okay, I need to. Okay, so now the transaction is in the transaction pool. It stays there. People could connect to this RPC from like their machines as well. They can initiate transactions. All of those are going to be accumulated in the transaction pool. Now, a clever way to design like an app on like an on-demand parachain would be, the interface will also give you an option to finalize this transaction. So what that wallet or that UI would do is it will also, okay, so this is getting annoying. Where is my, all right, so let's go, yeah. So it will also sort of pay the Rococo tokens required to produce a block for this parachain. So let's go here. For this, you would need to have like Rococo tokens on whichever account you're using to produce the block. Now the beauty of this is not controlled just by the Parachain team. Anybody can produce blocks on behalf of that Parachain if you set it that way. Let me go to the on-demand. Okay, so by now I memorized how many zeros I have to put here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So 4452, right? And submit transaction. Okay, I'm gonna sign the transaction. This is a nice time for me to advertise my project, like our team's project. So it's the same Open Zeppelin template. Like we've tested like extensively, like all the features, like Asset Hub integration, balance transfers, whatever. So we have already produced 162 like on-demand blocks. So there was a lot of testing done on this chain. So yeah, so you are able to. You can also connect to it. So this is the, so that's the RPC URL. If you go to the, this one, like web3educhain.xyz, so you can actually connect to the node that we're running on cloud right there, and then put your transactions in and sort of like finalize it like later. Fine. So let's go here. Okay, so then I want to just give you a glimpse of like what's possible. So till here it's fine. So any further you have to go, you need to understand some tooling. For instance, let's say you're trying to register your asset as a foreign asset on Asset Hub. So this requires like an XCM message. You've had this XCM like workshop where you've learned a lot of stuff and understood how it's done. So the cross-chain testing, there are multiple tools out there in ecosystem. So personally, we used Akala chopsticks. So it sort of lets you compile like your WASM blob for your Parachain. You'll have WASM for Rococo, Asset Hub, or whatever, and then they can like directly talk to each other rather than spinning up like the whole nodes, which is what like ZombieNet does. So it's very lightweight and it just tests like the runtime, and it's much more easier when compared to the other one. So there is also app development. Has anyone here heard of like Applon? Some of you. So this doesn't even like give you a choice, right? Like they already pre-select like some chains or some services, like storage. We selected this. So they just expose it as an API through which like you're able to build apps. So underneath you have like the Web3 technology, but it's sort of masked away from you. There are also like, if you're interested in mobile apps, there are like libraries to do so. If you're interested in games, there's a lot of so with Mythical Games launch, and then we've had like a bunch of games which develop traction. So a lot of work is going into bootstrapping like gaming ecosystem on Polkadot. There's even like a gaming bounty. So if you're interested in accessing. Yeah, and then a bunch of like APIs in Python or Substrate API. And then we have the author of Polkadot API in the classroom right now. And yeah, we also have like Polkadot.js. And then I want to show you like, don't reinvent wheel. There's a lot of like libraries that were funded for development through like Web3 Foundation grants program. So one of the key requirements of the grants program is that they have to submit the deliverable as like an open source code. So Web3 Foundation actually forks it and then keeps it for everybody, as resource to get started from. So you have all these categories. So we keep track of like, all the individual GitHub repositories. So they have like this status check showing whether they are actually like developing it or not. So take a look at that. There's plenty of code out there for you to bootstrap like your project, irrespective of like which project you're picking with the blockchain use case. And also make sure, like if you're building like an open source project, add a PR to the wiki and then sort of get it listed here for others to view. Let's go there. Yeah, and then I mentioned Asset Hub is the place where all the action is happening now. So a lot of liquidity is expected to pour in, either through ecosystem activity. We also have a bridge to Ethereum that was live this week. So we're expecting a lot of action on this particular parachain. For those of you who follow the ecosystem, you'll understand why we have like 1.3 million accounts on Asset Hub and only 133 active accounts. The reason for this is somebody decided Polkadot is dead, and then they launched a token called as dead. And because that token had to be on Asset Hub had to have like an existential deposit. So they emptied their pocket and sent like that tiny 1.1 dot or 0.01 dot to all of these accounts. So that's why you have so many active accounts on Asset Hub. So basically those are the stats for Asset Hub right there. And the beauty of this is, with all the optimizations we've done with Polkadot SDK, it has to show up somewhere, right? So you can actually see that on the Binance USDC transfer page. So you could actually see Polkadot Asset Hub is 10,000 times cheaper than Ethereum, 1,000 times cheaper than Solana, 100 times cheaper than Optimism. Basically, it's the cheapest. Like it's the lowest value possible on that page. And all of that is made possible with all the technology that you've learned over past 4 weeks. It supports like both fungible and non-fungible assets. Right now, I think this is a bit incorrect. Like this was like from a previous talk, but I think there are around 130 tokens that are minted on Asset Hub right now. So it's possible for the Asset Hub also to have existential deposit in either USDC or USDT. So it's called like what's called sufficient asset. If you just have this balance, even then like you'll have an active account. You don't need DOT to do stuff. And this is very contrasting to other ecosystems, right? Like so if you have to do something on Ethereum, you have to have Ether token. So whereas Polkadot doesn't really impose like DOT on you. Yes, if you have DOT, you pay a fee in that. But if you have some other token, you're able to use that as well. And Asset Hub is a system chain. So it's actually part of Polkadot protocol. And it comes with a lot of integrations. So that's the beauty of it. If you become a parachain, you integrate with Asset Hub. You're sort of proxy integrating with all of the others as well on there. So it's good to have that connection. Now, previously, the connection to Asset Hub used to require like governance. Right now, it's like a permissionless call. So you could just say, hey, I want to establish connection with you. And Asset Hub lets you connect in a bidirectional way. And this is important for agile core time. If we are expecting thousands of these on-demand parachains to get onboarded, we shouldn't place a lot of barriers on them, starting with deposit or having access to system chains. So this is easy. We already tested it on Rococo. So EduChain already has like a connection with Rococo Asset Hub. Yeah, the XCM activity is sort of picking up on Asset Hub, and then there was also this thing that the deposits on it were not friendly for artists. So we brought them like significantly lower, from 10 dot to actually 0.2 dot, and 2 dot for metadata. It's brought down to 0.005 dot. So if you know of any artists, just show them like Asset Hub, Coda dot. It's like a nice a UI. Let them like mint stuff on it and make this one popular because it's so cheap. In terms of bridges, like a lot of progress was made in sort of bridging protocols trustlessly. So the idea is that the bridge hub will always host code that is not multisigs, but it's mostly trustless communication, meaning Polkadot will run the light client of the protocol it's bridging to, and the other protocol is going to have probably smart contracts that is running a light client of Polkadot, right? So if you heard of this BEFI term, so it's bridge efficiency enabling finality yielder protocol or whatever. So that's the basically it's to enable bridge efficiency. Like grandpa proofs are like heavy. I don't know if you got to do the grandpa activity during this PBA. So it's possible to make them even more concise, and with like BEFI you're able to like talk to each other. So Bridge Hub currently hosts 2 bridges. One is to Ethereum, and the other one is to Kusama. So both are like trustless. Yeah, I showed this project to you already. And finally, what you should look forward to is the concept of elastic scaling. So this is one of the coolest features, I think, for like Polkadot and Polkadot SDK in general, because this is really bringing the existing cloud model, like in Amazon, if your app has a lot of traffic, it assigns more resources for it to sort of crunch that activity. So Ethereum sort of failed during the CryptoKitties movement, like it basically crashed that network, right? So we don't want such moments on like Polkadot. First of all, like we have an implementation that's actually, people try to spam it during the what was that called, ordinals on Polkadot or whatever. It didn't even hit like the block capacity. But if Polkadot has some activity and it's getting too much, you're able to, if you're a parachain on Polkadot, you're able to access for additional cores on demand, address that activity. Let's say you're hosting 1 million NFT airdrop. You do this, you use this activity, make users happy, and then after you're done, you sort of just stick to like one core. And yeah, so that is my contact details. Happy to answer questions or yeah.